Assalamu alaikum. Welcome to the first part of third lecture. Before we proceed to the actual topic of today's lecture or the part of the lecture, let us discuss some things which we already have done. Say for example, we have studied about events and their probabilities. For example, we are talking about head-tail experiment once again. So if I take the event that getting a head is my event, say for example my event A. Now the probability of getting head is, we know, 50%. If I take another event and name it to be not head, like I took another event which is something other than getting head, so that event I know is a tail, and we know that probability of getting tail is also 50%. So if I am taking, so this, if this was event A, this would be some event other than A, like the event which has points other than the points in A, not having the same points as those in A. So similarly, if I'm considering the experiment of rolling a die, so all the possibilities that I had, like the sample space for that event would be either I can have 1, 2, 3, 4, 5 or 6. So if I consider an event that having 2 dots on the face of die, if my considered or my favorite event is having 2 dots, then we know that the probability of getting 2 is 1/6. While we roll a die, the probability of getting 2 is 1/6. So if I define another event that not having 2, it is the same thing if I say that having any other outcome, like having 1 or 3 or 4, 5 or 6, having any other outcome other than 2, like just not having 2 on the face of the die. So if I see the probability of this thing, say for example this is my if this was my event A, this would be not A. If I introduce it with A and C on its top, so this would be an event that is other than A, that does not contain the outcomes which are the part of event A. So if I see the probability of this event, its probability would be 1/6 plus 1/6 plus 1/6 plus 1/6 and plus 1/6, that is 5/6. Similarly, if my event A is, say for example I'm assigning probability to the Pakistan's win and lose situation, so I say that winning of Pakistan is my favorable event or my event that I am discussing, and I say that there are 70% chances for Pakistan to win, so the probability of win is 70%. Similarly, the next event corresponding to it would be when Pakistan does not win. And does not win means Pakistan loses it. So the probability for losing or probability for not winning would be 30% exactly. So every such situation where we have any event A and then we take the rest of the part, the rest of the possibilities which are other than A, those possibilities are called the complement of that event. Like if this is event A, something other than A, all the sample points, all the possible outcomes other than A are called the complement of that event A. If my sample space is head and tail for a single coin toss experiment, if head is my first event, say for example event A, the sample points which are not head would be the complement of A, means the sample point which is not A is just the tail, that would be the complement of event A. Similarly, if 2 is my event A or B, whatever is my event, say for example B, then the sample points other than 2, that is 1, 3, 4, 5 and 6 would be called B complement, means those points which are the part of the sample space but they are not the part of event B. Similarly, if winning is my event, all the possibilities other than winning would be the complement of the event winning. So in today's lecture we actually want to learn about the complement of an event. If we define it, we would say it like this: given an event A, once we have any particular event, say for example event A, event B, and that event for sure would be defined in a proper way. The complement for that event would be the collection of all sample points which are not in A, which are other than A. So one thing if we notice from here, we would see that if I am adding the probability of head and the probability of head complement, that is tail, I am getting 50% plus 50%, that is 100%. 100% probability or probability equal to 1. Similarly, if I am adding the probability of getting 2, which is 1/6, and the probability of not getting 2, which is 5/6, so if I add both of these 1/6 or 5 and 5/6, I'm again getting 1. Similarly, if I am adding the probability of winning and the probability of not winning, that is 70% plus 30%, again I am getting 100%. So we would say that if we are adding the probability of an event A and the probability of event A complement, means we are adding the probability of A and its complement, it is always giving us 1 or it is always giving us 100%. Now what does that mean? Now consider this is our sample space. By sample space we mean the collection of all the possible outcomes for that particular random experiment. So this set contains all the possibilities, all the possible outcomes which can turn out whenever whatever experiment we are performing. So for example, this is my event A. What would be the A complement for that event? All the sample points, all the elements of this sample space other than A, that is if this is A, this whole region would be A complement. Now when we say that the probability of A plus probability of A complement is 1, by this we mean that the chances of something to be inside event A, the chances of something to be inside event A or the chances of an event to be inside A complement are 100%. That means we are saying that either something would be in say event A or it would be in its complement. Nowhere other than this, because if I am talking about the rolling die experiment, so if this is my event A, either my event A would turn out like either I would get 2 on the roll of the die or I would get something other than 2. There is no other way that something would come out out of these possibilities. If I am talking about head and tail experiment, either I would get a head or I'll have a tail. I can't have any other option for this. So we say that either an event occurs or its complement occurs. What do we say by this this simple line? It says that for any experiment that you are performing, either that particular event which you are considering, either your event occurs or its complement occurs, and for that thing you have 100% chances. If I say that I am tossing a coin, either a head would occur or its complement, that is tail, would occur. So if I am explaining or I am defining in the way that either I would get a head or I would get a tail, so for sure I have 100% chances for that event, that either head would turn out or tail would turn out, because I don't have any other option. So we say that there's no possibility that none of the event and its complement would occur. That's an impossible thing, that I say that okay, neither 2 nor another point other than 2 would occur, or I say that neither a head or nor a tail would appear when I toss the coin. Definitely either head would occur or its complement would occur. Either 2 would turn out or some point other than 2 would turn out whenever I am rolling a die. Okay, so similarly we can also justify the same thing from the case that if I take all the elements of event A and all the elements of event A complement, I took whatever elements were here and I took whatever people were there in the A complement, what do I get? I get the whole sample space. If I'm counting, I'm taking all the elements in the event A as well as I'm taking all the elements outside A, I'm taking the complete sample space. If I divide both the sides by the number of elements in the sample space, I would get what? This is the relative frequency of event A, which we named as probability of event A. Similarly, the relative frequency of A complement, which would be the probability of A complement, and this would become 1 or 100%. So that's all. So we simply said that the complement of an event is the collection of all sample points which are outside A event, and whenever we sum the probabilities of both the event and its complement, their sum is always 100%.